All right, let's do some practice of finding the local extrema if you have a function that has e to the x, or in this case, e to the negative x. So whenever I'm trying to find local extrema, which are max or mins, I want to find the first derivative. So that's my first goal, is I need to find the first derivative of this guy. Now, it's a product. So what that means is I'm going to have to use product rule. Okay, so the derivative of x is 1. The derivative of e to the negative x is itself times the derivative of the exponent, which is negative 1. All right, so that means that my derivative for this problem is negative x e to the negative x plus e to the negative x. Okay, now, to find my critical numbers, I've got to set this equal to 0 and solve it. All right, so this is where a lot of students are filled with dread. They're not really sure what to do. So the first thing you want to do is anytime you're setting something equal to 0 and trying to solve, always see if you can take a greatest common factor out. And in this case, I can factor out an e to the negative x, and I'd have negative x plus 1 left behind. So now it's in factored form. So now I would set each of these factors equal to 0. Okay, so e to the negative x equals 0, and negative x plus 1 equals 0. Okay, now, interesting fun fact. E to anything will never equal 0. That's the whole point of e to the x, or e to the negative x, or e to whatever, is that it will never equal 0. So anytime I get e to an exponent equals 0, that's never going to happen. Never, ever, ever going to happen. Okay, whereas over here, I'm going to get the answer of x is 1. So I do have a critical value. That critical value is x equals 1. Okay, now the question, is it a max or a min? We have some choices. We can use the second derivative test, but I don't know about you. I really don't want to take a second derivative if I don't have to. So instead, I think I'll use my first derivative test. So this is where we plot x is 1. I'm going to plug in a number less than 1. I'm going to plug in a number bigger than 1, and I'm going to see what happens when I plug it into my derivative. So when I plug 0 into this lovely derivative right here, I get 0 times this will just be 0, and then I'm going to get plus e to the 0. E to the 0 is 1. So 0 plus 1, 1. It's positive. That means it's increasing. Well, if this is increasing, if this is going to be an extrema, then this side should be decreasing, so I'd have a max. But let's just double check. So if I plug in 2, I'd get negative 2, e to the negative 2, plus e to the negative 2, which would be a negative 1 e to the negative 2. Put it in your calculator. You're going to end up with a negative number. So it is, in fact, decreasing. So if I went up and then down, that means I have a max. So we have a max at x equals 1. Awesome. Now, if I want my y value, I would want to plug in 1 back into my original function. So 1 e to the negative 1 would be just e to the negative 1. So my extrema is a max at 1 comma e to the negative 1. All right, I hope that was good practice.